Man, Google is just pumping out new AI models at a crazy pace, and today we're taking a look at the latest one, Gemini 3.1 Flashlight. Now, this isn't another one of those super genius brain of the operation frontier models. Nope, this one's different. It's something you might actually find yourself using every single day. It's what we call a workhorse.
All right, so here's the game plan. First, we're going to break down what a workhorse model even is. Then, we'll get into its coolest, most unique feature, this adjustable thinking level. After that, we're going to put it through its paces, see how it does with a few challenges, and I'm not kidding, we uncovered one result that was genuinely surprising. And then we'll wrap it all up with a final verdict on where this thing really fits in your AI toolbox.
Okay, let's just dive right in. With Google dropping what feels like a new model every other week, it's becoming super clear that the whole AI game is evolving. It's not just about building the single smartest AI anymore. We're really starting to get into an era of specialization. And that gets you thinking, right? Does every single task you have really need an AI that's the equivalent of a rocket scientist? I mean, come on. If you're just summarizing a quick document or, I don't know, pulling some names from a list, using a giant, expensive model is total overkill. It's like using a sledgehammer to crack a nut.
And that's exactly where this idea of a workhorse model comes in. Just think of it like the reliable pickup truck of the AI world, you know? It's not a sports car, it's built for high-volume, high-speed jobs, the kind of stuff industries do all day long. We're talking summarizing thousands of documents, extracting data, stuff like that. For those jobs, speed and cost are way more important than raw creative genius.
And hey, this isn't just a Google thing. Every major AI lab is building out this whole spectrum of models now. You've got your frontier models at the top, the big thinkers like Gemini Pro and GPT-4. But then way down at the other end, you've got these nimble, super efficient workhorses like Flashlight. They're built for one thing, getting a specific job done fast and cheap.
Okay, but here's the part that makes Flashlight really interesting. It has this unique feature that's basically a thinking level dial. It lets you, the user, control how much brainpower it actually uses for any given task.
So you've basically got two settings. You can set it to minimal thinking, and boom, it's lightning fast, uses way fewer tokens, which means it's incredibly cheap. It's pretty much just a non-reasoning engine at that point. But when you need more, you can crank it all the way up to high thinking. Now it's going to be a bit slower, it's going to cost more in tokens, but it engages in much deeper reasoning to really tackle the prompt properly.
All right, theory's great and all, but let's see this thing in action, right? We're going to put both of these modes to the test on a real task and see how that thinking dial actually makes a difference.
So, for our first challenge, we didn't go easy on it. We threw a really detailed prompt its way, asking it to generate all the code for a modern, feature-packed website. This is a pretty tough task, designed to really push its limits on both design and coding.
And yeah, the results were pretty much what you'd predict, but it's cool to see it play out. The minimal thinking mode was insanely fast, spit out the code in about 7.5 seconds. But it cut corners. It completely missed key instructions like a toggle switch for monthly versus annual pricing. The high thinking mode, on the other hand, took over twice as long, used double the tokens, but it actually nailed it. It delivered a much more accurate result, and yep, it got that pricing toggle in there just like we asked.
Oh, and just for fun, we also had to create a fully interactive encyclopedia of the first 25 legendary Pokemon. And you know what? On this one, both modes did a surprisingly good job. We got functional, nice-looking results from both, which just shows you how capable even these smaller models are getting.
Okay, so those tests, they kind of made sense. But our next test, well, that one gave us a result that was genuinely, legitimately shocking. It showed this little model has a hidden flash of brilliance.
We gave it this classic AI torture test, really. Simulate the physics of 20 labeled balls dropping inside a spinning, seven-sided shape. This is notoriously hard for an AI to get right. It requires a really solid grasp of spatial reasoning and, understanding that objects still exist even when they're moving around.
So the minimal reasoning mode, it did okay. It got the general movement down, but all the balls were kind of weirdly clumped together, not natural at all. But the high reasoning mode, wow, it was shockingly good. The movement felt realistic, and every single one of those 20 balls stayed perfectly inside the heptagon as it spun around.
And this is what's so wild about it. It just highlights how surprising this was. This little workhorse model totally nailed a task that the big shot frontier models from just a couple of generations ago would have completely choked on. They wouldn't have been able to keep all the balls inside the shape. It seems like Google has figured out how to pack an incredible amount of smarts into a really efficient model.
All right, so let's bring it all home. After seeing all of this, what is Gemini Flashlight really for? Let's get to the final verdict and figure out how this all fits together.
Look, here's the bottom line. Flashlight is your go-to for high-volume, well-defined jobs. Think mass document summarization, pulling names and dates out of thousands of pages of text, classifying content on the fly, or powering simple chatbots. It is the perfect tool for any job where you just need to process a ton of data quickly and, most importantly, affordably. But, and this is important, you've got to know its limits, right? This is not the model you're going to use for some super complex, multi-step reasoning problem. And while it can code, I definitely wouldn't rely on it as my main coding buddy. For those kinds of heavy lifting tasks, you're still going to want to reach for one of the more powerful frontier-level models.
And that kind of leaves us with a pretty big question, doesn't it? Seeing these powerful, super efficient models like Flashlight pop up suggests that the future of AI isn't just about creating one single ultimate intelligence. Instead, it looks like we're heading towards a world where we have a whole toolbox of specialized AIs, with each one designed to be the perfect tool for a different kind of job.